Hello, everybody. Welcome to workshop number 5. Chat, live folks, where are we calling in from today? I'd love to hear. Hey, Caitlin. Here's what we're going to build today. Just a quick preview. Well, there might be 1 or 2 people still showing up. Hey, folks. Hello, DC. Awesome. Welcome. Folks, drop an emoji, drop a party react if you have been enjoying these workshops so far. We've got someone from Egypt, we've got someone from New York City. Awesome. I'm from Philadelphia myself, so we've got a couple of East Coast folks here. Awesome. Great. Well, let's kick it off. So welcome to the Physics Microgame Workshop. First of all, starting today, we're going to be working on the prototype. And so, for those who don't know me, I'm Naomi Eberle. You might see me around places as Frostman. Guys, my anniversary was yesterday for my first year. I'm so excited. Anyway, we've got people calling in from Brazil. All right, welcome everybody. This workshop is sponsored by Snap, and just for reference, today's August 5th of 2022. We're using Lens Studio version 4.25. A quick to the chat that just came up about watching older parts. These are all going to be available on the Snap AR YouTube. And so this is a recorded call, and you'll be able to go back and play through it later. I would actually recommend not following along specifically if you're live, because that's my style, I guess. This is kind of a workshop where I would want to go back through and pause. But again, for anybody who missed it, here's what we're going to build. We're starting off with our main idea of basketball, and we're going to pare that down to a testable prototype. That's the first thing we want to think about today, is simplification. What is the simplest version of the game that would be fun to test? So if we take the idea of basketball, like that could be a fully fledged, photorealistic, co-located, like, you know, has fouls using body tracking and stuff. But if we start off with that as our goal, that's pretty daunting. So let's look at how we can kind of iterate this concept to form, again, a prototype that we can test and we can have fun testing. Those are our 2 goals for iterating the concept. So let's refine the core idea and reduce barriers wherever we can. So what elements do we absolutely need to test? We're going to need a basket and a ball. It's not really the same game without those. And we're going to need a player. Now, we mentioned other players before, having multiple people, but usually for our testable prototype, it's going to be you testing this in Lens Studio. So you're going to want to think of it as a 1-player experience, and how can you get something that'll be fun for yourself. We're encouraging play here. And thank you for posting that in the chat. We'll have some other links coming to you a little bit later, actually. A court, we might argue that that's something necessary to have our table tracked free throw challenge, but that might not be necessary in all use cases. Remember, think of that as kind of a second step and reduce barriers to pare that core idea down. And what you can start out with is by stating the algorithm, which is kind of stating a set of steps. You can think of it as a recipe. State them in human terms, whatever language you're comfortable with. So if I'm stating our game in English, for me, user taps to shoot the ball. So we're going to want to tap interaction in some way to trigger events to happen. If the ball goes through the hoop, then you score a point and repeat. And we're going to see in a second how that can actually, even a sort of simple pared down idea can still expand a lot when you start to translate it into computer terms. For those who are unfamiliar with algorithm, we're talking about a step-by-step procedure. Again, it's kind of like a recipe. And so what we're going to do is we're going to give Lens Studio the steps that we want it to take using scripting components and physics components primarily. And those steps are going to define how it puts together our scene. So if we take our stated algorithm, we can start off by splitting it into steps like that, literally. So user taps, that's the first thing. It's good to look for cause and effect relationships when you're splitting these into steps, because that will influence behavior scripting, is something we'll look at later, where we have these trigger and response relationships. So change the wording a little bit to user taps causing the ball to be tossed. If the ball goes through a hoop, score a point. And when you're looking at conditions, you only score a point on the condition the ball goes through the hoop. So it's important to remember that that's a step that might not happen depending on other factors that go out around in the scene. And then we repeat after that, which we'll look into ways to do that. So when we start kind of breaking off these extra paths that we can take, it starts to make sense to transition our algorithm into a flowchart. So over here on the left, user taps screen. I've highlighted that in yellow because that is an event, and we want to start thinking about events that are going to happen and things that we're actually going to tell the lens to do. So user tapping screen is something that could happen at any time, and we want our lens to be able to listen out for that. So, and then when that happens, we toss the ball. We'll expand on that, technically later. Check if the ball goes through the hoop. Again, this is another type of event. So the ball might go through the hoop, it might not. If it does happen, then we score a point. Otherwise, we skip that step. And so we have that branching option there. So real quick, what makes a scene? For the, if you're kind of like new to Lens Studio, it is important to kind of think about what a couple specific terms that we'll be looking at in Lens Studio. Objects and components are a big one. So objects are things that are actually in your scene. They're things that your user is going to see, and that's like what you work on in your scene panel when you're like moving stuff around. Components are like a transform component, like a render mesh visual, might give your object a visual. They define attributes and the powers of objects and kind of things that they can do. We'll look at physics components and script components today in particular, which are kind of your key building blocks for building this flowchart. Resources are references and blueprints that can be replicated in your scene. So these don't actually live in the scene, and once we get into Lens Studio, we'll see that a little bit more. But remember that objects and components are in your scene. Resources are kind of other references or other assets that define how objects and components look and what they can do in various ways. And then events and actions, that's our flow chart. And and the chart itself is a little more abstract, but it's made up of some kind of web of events and actions and physics calculations and simulations that are going to influence what actually happens in the scene as it's loaded. It's not just like a landscape or a still life. We want something to happen. So we want to think about that events and actions chain. So let's start off by investigating. And the name of the game is mess around and find out. Take chances, make mistakes, get messy. Let me know in the chat if you know where that's from. Only real 90s kids will remember. Only real 90s kids will remember those weird articles that they had like 10 years ago. But what we want to do is first, we're going to move into kind of exploring the physics template and seeing what we can learn just by looking at what's already there. We're going to try and break stuff. We really want to just experiment. So I'm gonna go over to Lens Studio. We have our physics component, physics template open. And just for anybody who wants to follow along later, you can go up to File, open a new project from template. We are using just the plain old physics one. For reference, that's the one with the little falling apple icon. Again, Lens Studio 4.25. And if you're viewing from the future, hello, and we love you and we hope you're doing well. So what does investigation entail? Well, first of all, we want to start off with just messing around and seeing what's in there. Let's look at how we can investigate this first example in the objects panel. So here's our objects. This is everything that's in the scene. We have a lot of deactivated examples. We are going to look at like 2 of these today. And so I encourage you to take some time, dive in later. Reason 1 for investigation is that it's a great environment to learn how the whole system works, because there's a bunch of examples in here where it's already working in a certain way. And so what you can do is kind of change one thing at a time and see how that influences it, and see how that changes what's going on. So if you look in our preview, we've got this dynamic enabled and dynamic disabled box. All right, so if I refresh the preview, the dynamic one falls. All right, so we've got objects that can fall based on gravity. And it's actually landing on this floor as well. So what the physics template allows us to do, not only can we apply forces to things, but we can actually have them, crash into each other and collide. So let's take a look at that dynamic box, and in the inspector, which if you are on the default window layout, your inspector might be on the other side of the scene panel. I've moved mine over here because that I like thinking about that as kind of the way that it's very closely influenced by the objects and the resources. And so we're going to be exploring a lot of the ways that these 3 window panes interact with each other. And that's where we have our objects, our components, and our resources, those 3 main scene parts, other than the events and actions, which we will see happen. So let's select that dynamic box physics body object. So it's got a box visual, it's got its regular transform, and it's got our first physics component we're going to look at, the physics body. So that has various settings, and looking at this dynamic example, let's start there. We're gonna trace that sort of series of breadcrumbs, and that's what we want to do, is kind of like reverse engineer what we see here and try and figure out, like, so if we find that dynamic property and uncheck it, refresh the preview, maybe obviously it's going to behave the same way as the dynamic disabled. Okay, we could probably have guessed that would happen. Looks like with the dynamic settings, we can change some various forces and features. All right, that's interesting. Another one I'd like to check out is intangible. That sounds kind of interesting. And when we check that, if you'll watch over on the preview, when I turn on intangible, it's suddenly able to fall through. So, all right, so we've got dynamism, we've got objects that can, respond to forces. They can crash into each other or not based on the intangible setting. I'm going to turn that back on just to get us back to standard template. And let's look at the ground as well, because that is an important part of the scene. I clicked on it in the preview. I want to click on it in the scene. And I'll notice that, okay, my ground actually has a slightly different physics component. It's a collider. So the dynamic box, if it will select, okay, both the dynamic box and the static box have this physics body component. The ground has a slightly different one, the physics collider. And, as we look through this, we can kind of try and find differences because it looks pretty similar, but you'll notice that it doesn't have the dynamic property. And but we can set this one to be intangible, and it'll have a similar effect where the dynamic object can fall through. Real quick to answer the question in the chat, the name of the template is physics. It's just called physics, and you can find it. I like to go to all categories just because it has all of them. So physics, not physics toys. We're just in physics, and we're specifically looking at the dynamic setting example. Thank you for asking. So as you explore, you learn more. We've got that relationship between the physics body component and the physics collider component. Those are two of our big building blocks for the physics system. Pretty much the only difference is that the physics body can be dynamic or static, meaning that we can have it respond to forces in the scene and move around, but also that's a trade-off with a little bit extra kind of performance for the lens, because it'll be extra calculations. So a physics collider can allow us to not have to do those extra calculations. So as you explore, you learn more. Pardon me. We've also got, with both of them, that relationship between tangible and intangible, and we have collisions and overlaps. Just to look real quick at a couple of the others, we have collision and overlap events, and keyword events also. I always forget, but I'm desensitized to it. Just so you know, the collision event has sound. I'm hearing that through my headphones. So when you turn it on, it freaks me out every time, but we're good. So we can actually have events based on those collisions and overlaps that happen based on the physics calculations. So here we have when Mark's feet collide with the keys, it's causing sounds to play. If we look through some more of these, like with overlap, we can have the colors of these delivery folks change as they're getting near to these boxes. So all of this stuff is things to kind of think about for later, for as we start to build our lens. But I seriously encourage you to go through all of these when you can and play with them and turn things on and off, test settings, because as you explore, you learn more. And the second reason is, as you explore, you find good stuff. So here with the set velocity example towards the bottom of the objects panel, we have a use case that's actually pretty close to our definition for our free throw challenge. Tap to shoot, that's exactly the same. The chicks like to get stuck in this little cannon here. I'm going to refresh. And our ground is still intangible. I'm going to turn that back because the ground is interacting with all of the examples. It's outside these examples. We have projectiles, and we have they look like boxes. They're not really rolling around, so we're going to have to do some tweaking. But this is a great starting point, and there's so much that you can find. And so keep your use case in mind as well as you are going through this investigation. If I turn the cannon off real quick, in the kinematics example, there's a lot going on. I'll just delete a couple of these for simplicity, but having my concept in mind, okay, we're going to want a basket or a hoop, and this looks like we kind of have something like that. So it's just made of a bunch of little boxes. So another thing that we can kind of save for later and merge these two examples together to get to our starting point a lot faster. And so my mom always says, clean as you go. So important. I'm gonna delete several of these that we won't be using today, just to make it easier to go through our scene. Highly recommend. Whenever you can, just keep your scene simple, like this face camera examples. We're only going to be doing a plane tracked experience, so we won't need that right now. If I could click on it, There we go. Awesome. So our objects, our scene is a little bit easier to read now. So let's get to extraction. Or investigation a little bit deeper into a more complex example, the set velocity. What we want to look for here is how are objects, components, and resources interacting in our scene to create and respond to the various events that are happening. Basically, what we're doing is we want to, the same way we built a flow chart for the free throw challenge we want to build, we're going to kind of figure out the flow chart by tracing the breadcrumbs and seeing how all of these three different scene parts, I keep wanting to call them components, that's one of them only, but see how they all interact to create the flow chart for set velocity. And one of the best places to start is with script components, especially script components that use the behavior resource. Those are going to be your big building blocks for cause and effect relationships. And of course, this is a physics game, so we'll want to look for the physics components that are influencing what happens in the scene. So, all right, I'm gonna hide our kinematics for now, and we'll grab that hoop in a little bit. I'm going to enable once again the set velocity example, and there's actually two cannons in here that use a slightly different method. We're just going to look at the behavior script one today, so I'll disable set velocity API. And so when we open up this set velocity example, this is just for organization purposes. It just has a null transform, 0 for position and rotation, and 1 for scale. So we can ignore that for now, but already we have a script component here for our cannon. So that's great. What have we got going on here? So this is a behavior script component. That is one copy of the behavior script, which can be used multiple times in the scene to create multiple cause and effect relationships. And here's where we can see resources interacting with the components. So this script component is essentially taking the behavior blueprint. What that actually is, we can right click on that and highlight it. And that'll highlight it in our resources panel. I know I told you we weren't, or I hope I mentioned we weren't going to be doing any scripting today, but just to take a look at this, this is a super long script file that already exists and is optimized for us to be able to use. That it's a blueprint for like basically any type of cause and effect relationship you would want to have in your scene. And when we have it, when we attach it to a component, to a script component, that is that becomes just one implementation of that script, that cause and effect relationship. And we can take a look very specifically. Every behavior is going to have a trigger and a response type. That's your cause and effect. So in this case, our trigger is tap. There's no touch target, which for the script, it's pretty smartly built. It can assume a lot. So in this case, when there's no touch target, that means the whole screen. All right, there's more options for any example or for any type of trigger or response that are specific to each type, but every single one, trigger and response. And its response is pretty interesting. In this case, we are instantiating a prefab of this chick physics body. And so I'm going to highlight that as well, because in a similar way for how the script file is a blueprint for the script component, a prefab is a blueprint for an object or a group of objects. So we've got these kind of blueprint resources. These are a major type of, or a major function of the resources that they can often be used to replicate things in your scene multiple times, and they can do similar things, but depending on how they are implemented in the scene, each copy of it each script component or each instance object of a prefab resource will behave, based on the rules set out for itself, but potentially in slightly different ways. And so, so this prefab again is a blueprint or a template for our object within the scene, and we have one right here. And you might notice that every time we refresh this, and I'll wait till the cannon goes back down, it automatically shoots one out before we tap. So this one is actually our, this is kind of like chick prime. This is the first instance of, or like, if you want to think of it as like the zero instance of, like the patient zero of the chick prefab. This is what we can use to kind of build it in scene and put the components and child objects that we want onto every prefab. And then with prefabs, we can apply those changes to the blueprint. So this is kind of what we can use for testing. And you'll see that if we open up its children, it has just one child object, which is this chick low render mesh visual. So that is that's where our visual is coming from, and then the physics is completely handled on the object. Okay, so let's back up a second. Let's see this. Let's see what we'll review this Canon controller. So it just has this one script with tap to create a copy based on the blueprint of the chick physics body. It puts it in the parent space of this cannonball parent, which we'll get to in a moment. But we don't want the chick, we want the ball. So let's actually start modifying this now. I'm going to pull up I'm gonna pull up some assets, and I'm gonna import a ball model. This is gonna be we'll make this available to you so that so you can have this copy. I apologize, my scroll wheel is acting funky today. It's going up and down. So I'm just gonna import that object for us. I just want to do a real quick shout out for the asset library, which is up here. This is such a great way to find stuff that might not really be in your template that you're looking at. You can click into here and search for like ball, for example, and we have this this Bitmoji sports pack, which just has a bunch of models that are ready and primed to use in your lenses. So that is such a great way to quickly pull some assets in to help get towards that fun testable prototype. So with FBX imports, it's a little tricky. They have a specialized object kind of within a folder. So I'm going to pull this inner ball model from our imported FBX in as a child of our initial chick physics body, and I'm going to rename that real quick to be our ball prime, because this is what we want to use to write the blueprint for the ball. So I'm gonna make this a lot smaller. That's crazy. We don't want to play that big. Oops, too slow. I'm gonna go down, and I'm just pressing arrow keys. If I hold Alt, it'll go a little slower, and I think that's good. So now I'm going to go back out to my main prefab, and I'm going to apply those changes. Remember to always apply. If you change any of the objects inside of it, or if you change any of the components on it, it's not going to do anything until, oops, it still has the chip. I'm going to delete that just to show that it's not. If we refresh the lens, we've got that ball prime that flies out on its own, but everything after that is a chick because we haven't updated the prefab. So I'm going to apply the changes we made to the ball, and let's refresh. So now every single one that we blast out is going to be a ball. All right, great, we're a little bit closer. So the ball is created, but what actually causes it to move? So ball prime, our reference object for the blueprint, has a physics body. Great. It also has a script. Awesome. So we're getting back into our building blocks here, and it's another behavior script. So that's great. We have another cause and effect happening here. Here we have OnAwake, OnStart. The trigger is basically as soon as this ball and everything inside of it is all ready and loaded. OnAwake is like kind of as soon as it exists, but it might not have everything that's attached to it ready yet. So when we use OnStart, that means as soon as this object is created, and that's going to apply to every single copy of it. So each instance that is generated by our Canon controller behavior script is going to call its own behavior script as soon as it's created, essentially. And the response type is going to be a physics apply force. So it's going to apply force to nothing. Again, another example of how the behavior template or the behavior blueprint is kind of knows what we want. It has some ways to search for objects and components. So if we don't specify something here, it's going to assume that we want to use the physics body that is attached to the same object as this script component. So this blank automatically references this own physics body component. It's a box. That's weird. This isn't basket box. Let's change that real quick and apply. Always remember to apply. Unless you're testing, in which case you might want to do some tests, and if they don't work, then don't apply. But once you get to a place that you like, apply it. And if we refresh this, now it can roll around. Amazing. And just, well, we don't need to look into that too much. So, okay, let's look a little deeper into this adding force script component. So we have it's adding force to its position, it's setting its velocity directly, and it's using this this just -400 in the x vector. All right, that's a lot of math, but I'm going to show you real quick how it's actually avoiding doing some math. So this is our first example of rigging in ways that make us not have to do so much rigging. Every copy of the chick, or it's the ball now, pardon me, every copy of the ball is going to add this -400 x velocity force to itself within the object space of the Canon object. And as always, you can right click and highlight to find the Canon, which is right here. So what's happening there? The Canon object has its own local space. And so when we tell the chick to use that space, what we call the x vector is changing as the Canon goes up and down. So that way we know we just want it to go forward out the Canon, and we have the Canon handle its own rotations elsewhere, which we'll look at in a moment. But that way we can just we don't have to like calculate all those angles or anything. We can just give it one force out that direction, depending on, and that direction will be depending on wherever the Canon is at that moment. Now, let's take a look at that Canon just to get a little bit of a sense of it. It's got a visual and a transform. It has another script component. Now, this one is a tween. Anytime you see a tween, that's going to be like a scripted animation. So what that's doing is we're just rotating back and forth over and over between these two rotation values every 4 seconds. So now we're starting to get a sense of the flow chart for this scene. We have our first behavior block, and again highlighting the event in yellow. Skipped ahead. As soon as the user taps the screen, create an instance of the chick object based on its blueprint. as soon as the chick object starts, it applies speed to itself, and it's using whatever is the current local space of the cannon, which we've pulled apart just because the direction of the cannon, it's always going to be changing. And so that is always going to be influencing what happens in our flowchart, but it's not really part of the main cause and effect relationship. So something to keep in mind. And in the end, that will cause the chick to be, I keep talking about the chick. I got to this slide late. It's a ball. It's going to cause our ball to move based on physical factors like whatever its angle and speed is at the time of the launch. That's going to be relative to the whole world space. Like the gravity is always going to be pulling it down. So the physics simulation calculates a lot of that movement for us based on those, just those inputs that we set up. And of course, it's going to collide into things depending on the shape of its box or ball or like a capsule or cone or something. It's, those collisions are going to behave a little bit differently. And so that's essentially what we've got going on with this example. And so by kind of tracing this flowchart and trying to put together which things are talking to which and which are bringing in like what resources and components, we can start to form a picture of what's really going on here. And you might be wondering, like, this whole instance thing seems a little bit indirect. It seems like there's like it's a little too complex. And so just a quick important thing to note about that is when this first behavior script runs, it doesn't know yet the name about the object that it's going to instantiate. Remember, this is like an anonymous random copy. Each one is going to, each one is going to be slightly different, but this first behavior is not able to reference these second behaviors because they're not necessarily created yet. And that's why we have the difference between OnAwake and OnStart. OnAwake means that once the prefab itself has been created and this script component exists, it can start thinking and it can start kind of like running through, okay, preparing, like, what's my behavior going to be once I'm ready to start. And so that not only is the each object instance able to refer to itself directly, it simplifies our scene by taking a little bit of extra work away from the Canon controller. And so just a quick recap, we have the physics body that can respond to forces as being dynamic. We have the physics collider, which is similar but can only be static. Both of them can be tangible, meaning they can collide, or intangible, meaning they can go through each other, but they can still overlap. Scene flow, remember we're looking, when we're investigating, we're looking for our behavior script components. That creates our trigger and response relationships, which form our main web of scene events. Our scene is composed of objects, components, and resources. Objects and components live in your scene, and resources are references for the objects and components or parts of them. In particular, again, script resource is a blueprint for a script component. Each script component will be a little bit different, but they all follow that same blueprint. Same with prefabs and objects. They're all going to follow that blueprint, but that could create like slight differences between each object as it's created. And we've looked at local transform space, where every object has a 3D space relative to itself, and transforms kind of, you can kind of think of them as components. They're technically a little different, which we'll see in the next session of this workshop, but transforms live with the components, and so that's kind of like the basic attribute of every object. Sorry guys, I have a train, like there's a train track right next to my house, so apologies for that. And parenting is a way that we can use those local transform spaces and leverage them to do less math, and also for just scene organization. Like with the set velocity that has 0 rotations and positions and 1 scale, that's just for organization. But in the case of our objects in the scene, that can actually influence the vectors that that are going on with children of that object. So let's start to extract. Now this is the fun part. This is where we start to merge templates together, and we're going to do a little bit of this today and carry on next session. Ooh, I almost spoiled the good part. So let's take this Canon controller. This, our set velocity behavior script example has this Canon controller, and everything's kind of happening inside that. So one thing we don't want to do in this case is select things in the scene, because when we're dealing with very specific components and sort of scripted things, like this Canon has no render mesh visual component, meaning we can't actually select it in the scene, but we definitely want to move it wherever we want the whole projectile portion to go. So like we don't want to select just part of the Canon. I'm gonna hide a couple of these plane tracking things real quick. We don't want to just accidentally select part of the Canon or even everything visual and then leave behind that main controller. But all right, let's think about shooting the ball from the user's perspective. So we'll move that whole Canon over to our camera, and it disappears. What's going on? Well, remember, the camera has its own space. So as soon as we make the whole Canon group I'm gonna rename that Canon group. As soon as we make the whole Canon group a child of the camera, it's going to follow along with the camera wherever it goes, which means you can kind of see, I always forget the camera, it stays the same size and gets bigger. So it's following alongside the camera now, which means as the camera moves, the Canon is off to the side here, it's always going to be off to the side because it doesn't move any other way. So let's move that into the camera's field of vision, and now you can kind of see that the Canon looks fixed to the screen because now it's following along with our camera, and it's not following along with the ground plane anymore. So awesome, we're getting there. And we'll move it down a little bit. And now let's test it. And when I tap, weirdly nothing's happening. They're all kind of getting caught. So all right, let's dive a little deeper again into the object. We've got some other objects we didn't look at here, a bunch of colliders that are kind of as part of the rotating Canon, and so those are forming a bunch of walls essentially that are a tunnel. We'll just toss this from midair, so we're not going to need those walls. I'm going to deactivate all of them for now. We'll keep them around just in case they're needed for later, but let's try that again. We tap, and still nothing's happening. So what the heck is going on here, people? We've got our scene web again. I'm gonna go back to that slide real quick. We're tapping, and then we get to the object starting, and it should be applying a force to itself, but it doesn't look like it's doing that. It's not crashing into the walls anymore. And so what we'll find, and what we're going to dive into first when we explore the next session, is we are experiencing a little bit of a, I don't want to say bug because it's not like, it's not a broken functionality. We have multiple transform inputs coming into our ball. So basically, the camera right now is the entire parent of the Canon group and everything inside, including every ball that gets created, because they all get created within this parent based on what this script told us. So that's one transform input where every frame, the camera is going to be moving and it's telling everything inside it, yeah, also move along with me in my local space. Then we also have the physics simulation going on. So there's gravity that's set to be relative to the space of our plane tracker here. So every frame, those two inputs are kind of fighting each other. Like the camera's saying, come with me, and then the physics forces are saying, no, go down, because gravity. And so what happens, and if we completely hide all of these, I'm not going to totally hide the cannon, so it still moves. Even once we hide everything else that is not directly involved in our script behaviors. So remember, we've still got this behavior script enabled. We've still got each ball's behavior script enabled. So this should be just applying a pretty huge force to this object, and it's not, because every frame, those are kind of fighting with each other. So for next time, I want you guys to think about ways that we might be able to get around this. We'll explore one particular way, but try this out. We'll have files available as well. So do some experimentation and mess around with the physics template. Figure out what else there is. Like there's constraints. We've got a couple of links here, which I wonder if they'll be still copied. They will. Awesome. So you can let me make sure this goes to everyone, and we are officially in Q&A period. So if anybody has any questions about what we went over, let me know. But otherwise, we're at step 1 of our prototype. It's testable. You know, we are able to do testing on what's pretty similar to our game, and now we get to figure out how to make it work, and we also get to figure out how to make it fun. So we'll dive into that next time. How are we doing today, folks? I guess I don't see any questions yet in the chat. While we wait, we can just pull some of our scene together. We can take this this rail, take the hoop, make it a little smaller. So we're at a point where I'm gonna turn our game back on. What are the forces based on? Like in the Blender, gravity is -9. Great question. Okay. And another question about the screen space. So I am gonna have to get back to you on the forces, because I know there used to be a gravity component, and I believe that changed. But but the forces are based on units, and so with these various settings for ways that you can apply force, we're just applying a direct velocity. So it's just instantly like creating energy and creating the velocity. Oh, I'm glad you found it. We'll go over that anyway. Sorry. There's other ways though, and one of the examples, which unfortunately we have already deleted in this file, but there's like 12 different boxes where you can kind of explore like how the different force settings create movement, and there's a lot of complexity just within that. There was, but I can't find it. I'm not sure what that refers to. So these, they are based on physical attributes, and I don't remember offhand what the scale space is here. But yeah, it is in the Lens Studio documentation, which which is in the link I provided above, and it'll be in the YouTube description. That's definitely documented about like what all of the units are exactly and how they interact. And someone in chat was asking about how to find the inspector window. Found it. Awesome. I'm gonna go over it just so that we all know. So and I'll kind of show like why my setup is a little weird, because I touched on that a second ago. But what you can do is, if you go up to Window in Lens Studio and Panels, you can, if you're ever missing windows and you're like not sure where they are, you can go to Default Layout. And so usually the inspector will start over here. I should have started it over there to show it earlier, but we can, what I liked to do is just move the inspector over so it's close to the objects and resources, because the inspector is kind of like your components panel. So it's nice to, for me, I think it's nice to kind of have those all in one space, because like they're I don't know, they're all the lists, and that kind of like forms like just how your scene is set up. So in the preview, if it's not showing this example, it might be that you can go into, if you open up the physics example again, for me it defaults to this video whenever I open up the physics example. So you can try turning it off and on again. There are other ways though. So you can go up to the top here, and if it's your picture, actually you can click on this object. So like this, you might be set to webcam mode, and that will potentially show me. I think I have my video on Zoom, so it's not going to, but awesome, it worked, good. Yeah, so this button can get you to the preloaded videos. Another one that I like is that for production environment lenses, it's definitely important to think about how the rest of the lens or the Snapchat UI is going to factor in. But for testing, just to make it a little easier, if you click on iPhone 8 or whatever model you have selected there, and down at the bottom corner where it says showing sponsored UI, if you click this little one with the X, it'll give you a totally clean screen, which can be just a little easier for seeing like what's going on in your lens and like focusing on that. Oh, I really love trains. I've always been a train kid. I was so excited to see this the first time. Wonderful. So if we have any last second questions, any buzzer beaters? Looks like we might not, so that might be a good spot to call it and get ready for session 2. So session 2, we're going to be, taking what we have here. We'll fix that information. Oh yes, contact info profile pages. Ah, okay, on Snap. Let me provide that. You can message me on Snap if you want to. I'm gonna be attach 8. Oh good, I'm glad you're looking forward to section 2. So you can find me there on Snap. My Instagram is another good one. It's anti-alias with a dot in it, but it's anti like aunt and niece and nephew. So that is spelled like that. Make sure there's no typos like there almost was. And anti-alias is a similar one that I use for some other socials. And I'll be on YouTube as well. So if you have any questions once this goes up on YouTube, I'll be there in the chat and able to answer questions there, and that'll be great because we'll have directly available. The video, it'll be all in kind of one place. My email that I use for that is one of the places where you'll see my old name. Still haven't changed yet, but Naomi Rossman is my main one. So yeah, definitely let me know if you think of questions along the way. Let me know if you think of some way that we might be able to kind of get around the weird multiple transform inputs that we had going on. Yeah, those for anyone who is on YouTube, those the contact information will all be available. We'll probably be able to have links for them, so it's a little easier. So yeah, that'll all be available in the description. So check back soon. And if not, I'll see you on the 19th.